Welcome to another lecture on CS102. So we missed the last two lectures due to technical issues. So now I will be focusing on the last part before the midsem. So this is about the number system and why number system is so important in computer science. Remember one thing, in computer science, eventually everything is binary, right? So every instruction or everything that you do eventually goes in the form of zeros and ones. Right. Now, what is the issue with having a binary number representation or having other numbers of representation? So I have an image shared here. So in the Dropbox also, you can actually see these images. So basically, you can go to your Dropbox CS102 and you can come into May 12. You have some images and May 13. These are basically the steps how to convert the numbers from one form to another. Okay. Right now, we have a chart of numbers that consist of decimal, binary, octal, and hexadecimal. I will come to you one by one on each, right? So first, let us just connect here in the pen mode, and let me keep this on top. Okay, so let me. Okay, so now this is on top. So let me just write the number system. Okay, so the first number system here is binary that we deal in computer science. We have 0 and 1. So basically the set of binary has only two numbers, 0 and 1, and hence it is called binary. So bi means 2, right? And then we also have a number system which is decimal that we study from our childhood. Decimal is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. From 0 to 9. So if you see, there are total 10 digits here, right? And there are 2 digits here. So we have 10 digits and hence the system is deca, right? Deca means it's a 10, a deca represents 10. So when we say a decimal system, it means it has a unique 10 digit system, right? So all other numbers are basically constructed using the 10 digits that we have. A third kind of system is octal. Octa means like we have octagon. So octagon has 8, right? So this goes as 0, 1, 2, 3, 4, 5, 6, and 7, right? And finally, we have something called hexadecimal, right? So this is kind of a strange number system. I also have the table here. You can see it goes from 0 to 9 and then A, B, C, D, E, F. So let me just write it for you. Oh, sorry. After 9, basically there is no 10 here. It is represented by A. So let me just erase this. So after 9, we have A, B, C, D, E, and F. So basically you can see the decimals. If you see in this particular chart, we have 0 to 15, and in the hexadecimal we have 0 to 9 and then A, B, C, D, E, F. Fine. So now when we call this system as hexadecimal, right? Hexa means 6 digits, that is hexagon has 6 sides, and decimal, as you saw, it's a deca, it has 10. So 10 plus 16, basically it has 16 alphanumeric, I should say, because it has some alphabets also, right? So just ignore this. This is 16 alphanumeric. Fine. Now, why do you require a number system in computer science when you already have so many? Everything will be binary eventually. Then why do you actually need decimal, octal, and hexadecimal? See, the problem is binary in that it is difficult to interpret, right? So let's say if you want in decimal, the representation of let's say 9 is 1001, Now just imagine how difficult it would be if you just say, okay, come at the lecture which starts on 1001, right? Very difficult for humans to interpret and convert them into this particular format. Also, there is an issue of space. So for example, let me take a number, let's say 9876, right? Base 10 means it's a decimal number, right? So it's a decimal number. The conversion or the equivalent binary form of 9876 basically is 100110. So do you see, it is such a huge number, right? So let me just change the pen color. It's huge, right? So even a 4-digit decimal number, right, it takes a huge amount of space for its representation. So when we have larger numbers, this number goes very high and it is difficult for humans to operate also, right? To save space and make it more readable, we actually have this number system: binary, decimal, octal, and hexadecimal. Basically, you need to remember this particular chart, how it is derived and what it contains. So basically, decimals you of course know, 0 to 15, and octal, right? So octal is 0 to 7 because it has 8 digits. Now interestingly, there is no 8 here, right? Because if you see the set of octal, it basically completes at 7, right? Now let us see how does the digits actually get formed in a decimal system. So now in decimal system, after 9, basically you are getting 1 and 0, right? So how did you construct 1 and 0? You completed the 9 digits. Now what you do, you start with 0, right? But starting anything with 0 has no sense. So what do? You take the first digit, right? You take 1. Then for the 1, now you attach all these digits. For example, if I say you the decimal has like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Fine. Let me change the pen color to, let's say, black. So now I take the first digit, which is 1, and beyond these digits, I will put all the digits that are basically belonging to the set of binary, right? So you just keep this particular thing here. And now let me expand this particular digits. Let me take another color. So it will be 1 0, that is 1. Then you have 1 1. Then you have 1 2. Then you have 1 3 and up to 1 9. After everything with 1 is over, you can start with 2, 3, 4, and so on. And then basically you can start with these digits and then add the binary representations again and again. So this will be 1 0 0, that is 100, 1 0 1. So this is how basically the number system evolves. So any number system with any base, like octal is base 8, right, because it has 8 digits. Hexadecimal is base 16 because it has 16 digits. Binary is base 2 because it has 2 digits. So now just see, for example, in octal representation, so you can see after 0 to 7, how do we represent the number in a similar form? So let's say I write here octal. It is 0, 1, 2, 3, 4, 5, 6, 7, right? Total 8 digits are over, right? So how do you know, how do you calculate the digit after 7? So let's change the pen color. So you start with 0 and say this is like 0 0 0 1 0 2 0 3 0 4 up to 0 7, right? Anything before, I mean, if 0 is before a number, it makes no sense. So what do? Now you start with 1, you pick the first number, right? You pick the first number and then keep all the strings as it is. I am just copy pasting this, right? And now just append them one after the other. So this becomes 1 and 0 is 1 0, 1 and 1 is 1 1, 1 2, 1 3 up to 1 7, right? Similarly for 2 0, 2 1, 2 2, 2 3, 2 4. So you can see in this octal representation, can you see this space? So let me just draw here. So in octal, basically you can see 0, 1, 2, 3, 4, 5, 6, 7, and after that you are getting 10, 11, 12, 13, 14 up to 17. After 17 it will be again 20, right? Because there is no 18 in the system. So this is how basically the number systems work. And now we will see how do we convert between decimal, binary, octal and hexadecimal. How do we convert from this form to this form? That is for the next lecture. Thank you guys for